we believe in delivering data-driven value at scale from across the enterprise to solve timely business problems. Hi, my name is Sajimon Joseph. I'm a senior principal architect at Comcast. This is how you can think of our typical data environment is. There are your clusters or data sits in on-premise or cloud, and then you have your various data stores where this data gets stored. And then all your query engines, your BI tools, all these different components that were accessing data, right? And then there were other concerns that you have to deal with in the data landscape, which is your compliance or security issues, as listed here. And at Comcast, we had a similar situation as well. And what we are showing here is what is our current status is. So I want to take you to this phases of processing that we went through. And the first thing is, think of data assets. This is where you had your raw data that lives in these isolated data sources, and people were happily querying them. But it was just isolated, and you had expensive ETL processes for transferring data from one source to the other, right? And one of the key point here is that you had limited security in this arrangement. And each platform, wherever this data lives, they had to, the users had to figure out how to deal with that data there, right? And then the systems evolved into what we call data fabric. So this is where Trino-like tool technology started shining, right? Meaning you have distributed data sets, this federated query engines, and suddenly users don't have to do expensive ETL process, right? And security got improved. Now you don't have to stick with whatever these underlying data platforms offer, right? You can have that single sign-on, or you can get authenticated once into this Trino-like technology, and then access the data no matter where it is located at. So this is what we got working at Comcast so far, and so we evolved from data assets into data fabric. So what I have shown here is a typical architecture, how this can be done. And there are 4 components I like you to pay attention to. And this is similar to some of the other presenters were done today. What you see is, from the end user perspective at the top, they access this entire ecosystem using a single endpoint. And the query, they submit a query, and that query goes through a routing layer. So that is going to use an ML engine to determine the query type, and then it will figure out which Trino cluster going to handle that query. And what you see here is, it's on the left-hand side, you will see there are 3 clusters, on-prem clusters, and then on the right-hand side are our cloud clusters. The end users don't have to know all these technical details. And the query router will determine which cluster is appropriate for running that query and inform the user. Again, user is not aware of it, it's happening behind the scene, and the query gets routed there. And we have data sets all over the place, but the beauty is that you can access all that data without knowing where it is located at. So the first point is single endpoint, then query router is the one component that is going to determine where the queries will be routed to. The third piece I quickly wanted to mention here is about our blue-green deployment. So at any point, any query that comes in, like that query router is continuously checking the health of the environment and can figure out which cluster is alive at that point, and that is where the query gets routed to. So it is all transparent to the user. And the fourth piece I quickly want to mention here is our the Trino to Trino connector. So what it allowed us to do is that catalogs or data sets from cloud are made available in on-prem and vice versa. So as an end user, again, they don't have to know the difference. And this actually enabled us to do something very, very interesting. We were able to move data from across these environments without the customers being aware of it. And for various reasons, right? For efficiency or security or high availability, we had to move data sets around, but the end users didn't have to know. So what is next? So this is our next phase, and that is what we call data mesh. So we were in data assets, then went into data fabric, in data mesh, right? This is where, if you look at how things were exposed in data fabric, you had data everywhere, there could be duplicates. The end users have to figure out at times, like what is available in all these different platforms. We wanted to provide curated data sets that are governed, they are secure, and they are compliant. I mean, all these qualifiers that I listed over there, those are like at least the minimum qualifiers we want to have with all our data products exposed in data mesh. Another key aspect of is that, I don't know if it's easy to read at the bottom, like this is a common layer. So what we are trying to say here is that the component that we call is Query Fabric, that is our Trino implementation. Query Fabric, Databricks, Spark, I mean, any engine of your choice should have access to these solutions. And this is what we wish to accomplish as part of our data mesh program, right? We want to have all these key criteria met. And so the data fabric does offer the ability to distribute the queries, but that data mesh in our space, we felt that it has to have that higher quality experience, right? So all these features that I listed here are essential for us to offer that data mesh solution. So here is how we look at that solution, right? You can have source aligned data sets, meaning you can create the curated data sets that are pure data sets, like imagine customer, right? So that is an entity that is well defined and it will be exposed as a data product. Or you can create this aggregated data products that are built on top of multiple instances. So that is what, in our world, what we call the data mesh, and is the different components associated with it. And what we expect to see is that all these data products comply with all these different requirements. There should be policy associated with these data products, and they should be discoverable. There should be lineage available, and data quality is essential, right? We want to make sure that the data that the end user receives are reliable, and they should be considered as a single source of truth if that is what the case is, and there should be easy access possible for those data products. So now let's look at a theoretical architecture for this data mesh implementation. What we are showing here is that there could be compute engines, which is what shown here. They could be in cloud or on-prem. And we have all the different data stores. Again, in cloud or on-prem, doesn't matter. And similarly, Query Fabric, which is our Trino implementation, that can be hooked into, again, the same data stores. And these are all discoverable through our enhanced metadata, right? And there is a mesh, we call it a mesh catalog. That is where all the metadata for all these data sets will become available. So it will not be just isolated to one instance. You will have an enhanced mesh catalog, then we will have enhanced discovery, and this is our governance component. This is going to apply that governance across all the data sources. So through this arrangement, what it allows us to do is that the data can be moved across all these different sources. It won't affect end users. They will still be controlled through that enterprise access control solution. And you will have a compute engine or a query engine available that can access that data no matter where it got moved to. And it is still discoverable. So the first I talked about that data mesh journey. And the second piece I like to, or second part of my presentation, I like to focus on the governance in the data mesh land. And there are so many components or details that we need to consider when you're talking about governance. But let's look at from these two key points, right? How do you control access to the data? And how do you manage privacy? So at Comcast, we believe that these are at least the minimum criteria we need to have covered as far as data access control goes. So you want to make sure that there is fine-grained access control possible, right? And I can go into a little more detail on what that means later on in the presentation. And you hear the term attribute masking. Definitely folks outside, I mean, some of the vendors out there definitely can talk about the specifics on some of these capabilities, but attribute masking, row filtering, then one of the features that we felt that is going to make a significant difference in our world, in our space, is tagging, right? Like initially when we started building all our access control, we had to, it was more like resource-based. We were controlling access to individual resources, and the users were granted access to at that individual level, but that won't scale, right? So whereas if you started tagging the data, that I will talk more about it later, it is going to significantly simplify the architecture and makes it possible to control access to the data because tags will follow the data. And on the privacy side, we want to make sure that we follow all the compliance concerns, or we want to ensure that we allow the end users to, the individual rights request are handled. Then we wanted to make sure that the data can be maintained based on whatever the legal conditions out there. So all these details needs to be addressed as part of your data mesh governance program. So I'm just going to spend a few minutes on some of the details that we just looked at. From fine-grained data access perspective, the way we want to do is that we want to inspect the data, right? There are solutions out there that can scan the data in an automated fashion. They scan and provide you where the data is located at. or what type of data it is. And then we have our data engineers or data owners and stewardship team. They will go and tag this data, right? So basically what they are saying is, oh, this is PII data, right? Or the meaning personal identifiable information, or it is customer specific data. There are so many different tags that you can define. The beauty is that once that tag is assigned to that data set, it get captured, and that lives on. As and when that data moves across the systems, like that tag lives with that data. Then when end users want to access the data, they will come to see what is out there, right? And they can request access, and it's all happening in an automated fashion that if the data access can be granted, it will happen, or if there is approval needed, it can be processed through that channel. So this arrangement suddenly gives access to the end users, right? That they don't have to go through manual process to figure out where data lives or how do I get access to data. So this fine-grained access is a key component in data mesh world. And you will see later on the way you can control access at an attribute level, like you can define data sets to be sensitive or highly sensitive or things like that. And that way, again, you are tagging the data at an attribute level. That is, so you can, I think I have a slide on it. Yeah, so here it is. You can tag a data set at a table level, right? Or for row filtering, you can tag them, you can define them with different groups. So a scenario in this case is like, imagine a table containing data from, say, US and European markets, right? You have a single table containing all that data. By controlling them by the groups, that row level filtering will grant you ability to control what gets what is made available to the end user. Again, all this information can be created through the tagging. Then finally, at the attribute level, that is at the column level, if you want to look at it that way, where you can provide sensitivity at the column level and say this data set is sensitive or highly sensitive. I mean, all these different categories you can define. But then what it allows you to do is that when the stewardship team or when a data steward goes and define these tags on a data set, suddenly you made this data set accessible in a fashion where end users do not have to worry about whether they are, how do I get access to this entire table? Instead, they will say, I need to access this data. If it is sensitive, it is going to be taken care of automatically by the system. Like as an end user, I will only be seeing what I'm allowed to see. So here is an architecture that we created for making this federated access possible. What happens is that our data sources, or we get the metadata from all the data sources, and they get captured into an enterprise repository. And our access control governance team, so this is the stewardship and the stewards and data stewards and other groups, they go in and tag the data inside our enterprise metadata platform. So you get the tags assigned to it. Then our enterprise policy hub receives these tags from that repo, and it continuously receives that. I mean, they have a sync happening behind the scene. Now, so now what here, the end user is, say, submitting a request saying, I need access to some data, right? So the access approvers will look at the request. If it is automated, like if the data access can be granted automatically, that will flow through in that fashion. Otherwise, the access will be approved by the data owners or whoever is assigned to do it. But the key here is that the user will be assigned to a role, and these access control managers over here, they are the one managing the policies. They will be saying certain roles have access to the data. These roles are tied to these tags. So as an end user, when you get assigned to a certain role, that role says, I mean, based on the tag, if the user has very generic access, that is, they have a certain role. That role says they are associated with the generic tag. So when they go to access the data, the effect of reading the data with generic policy gets applied. So all the sensitive data gets, they became hidden, or they will not be available to the user. Whereas if another user has access to a role that gives them sensitive access, then these tags will again become applied, and then the user get access to that data. So it's already working. I mean, this actually eliminated our the way we manage all the policies, or the way we have to create all those individual policies. So it significantly reduced, but ability to maintain or grant access was still possible, right? And at the bottom here, what we have shown is that the various engines, query engines, compute engines, I mean, you name it, any client that has the ability to interact with the policy hub, they will get a dump of all the policies, and the policies get applied at this layer. So Trino, for example, that is that query engine is you can think of. So it has that plugin that can take all the policies, and the policies get evaluated in that query engine. Then what ended up so that is what that policy sync tag at the very end over there. It means all these different components can get all the policies, but behind the scene they also will be feeding the results of that action through that audit log back into that enterprise policy hub. So we heard about data mesh, and I just talked about some of the technical side of data mesh. And by strict definition, of course, there is that cultural shift as well. And in here, what I'm trying to show here is that data mesh the technology is just one piece of the puzzle, right? So you want to ensure that you can offer the service level agreements or security, etc. All those key aspects are addressed as part of your data mesh program. But it's going to be successful only when the end users and other parts of your organization actually start adopting this concept of data product, right? They need to think of data as with the data product mindset, offer that curated data set, avoid data duplication. And another significant benefit of this arrangement is that it's going to help everyone to work together in or they talk in the same fashion, right? Everyone, when they look at, say, customer, meaning it will be the same across the various groups, right? So, and they should be able to work together, understand each one's requirement, and make sure that they are avoiding all the data duplication and creating that the value-added data sets. So here is what some of the challenges out there, and this is what we feel that needs to happen next. From efficient data mesh implementation, we need to have a mesh metastore that allows us to go beyond the individual engines, that allows us to have access to all the different data stores and get their metadata. And that enhanced data discovery that I shown earlier, that is another key component that a data mesh solution has to offer. So all these capabilities or entries that I listed here are features that needs to be developed or enhanced. So we are looking for other organizations to hear your thoughts, suggestions, ideas on these topics. We want to collaborate with you to make sure that we can deliver the next level of data access and address these concerns for a better world. I mean, make everything better. Here is my contact. So in case if you have any questions, please reach out to me. I think I have a few minutes for taking questions.
Hi, I have one question. So you have data sets on-prem and the cloud, and you also have the Trino compute clusters on-prem and on the cloud, and any Trino cluster can access either of the catalogs.
Yes.
So how do you avoid this network IO overhead and the cost of like getting from network to the on-prem and then the other side?
Thanks to the wonderful team of the Trino folks here, query push down, join push down, and so at Comcast we did something called global views and local views. So it allows us to create this curated layers where we can force certain compute to happen in a local cluster. So I don't have a slide on it, but that helped us to make sure that the compute get localized. But in cases where it didn't happen, like if we do not have a representation in that fashion, so we have the join push down, we are actually using PTF in our Trino to Trino connector. All these are great enablers in solving our data needs, and it significantly reduced our compute cost.
Sneha from the chat online asks, are there any alerts when tags contradict with each other?
I cannot. Well, the way it works is if you have a conflict, of course, I mean the system will actually block access, meaning so that is what this policy hub engine is supposed to do. If they are conflicting, it will always take the negative approach and trying to block access rather than grant access to the user. So they make sure that there is no accidental access to sensitive data. So it always takes that restrictive approach than taking a chance. Does that answer the question?
Yeah, thank you.